excuse me. Warm-up number 8, complete the relative frequency table. Make sure you notice that it's a relative frequency. Yes? All right. So let's see. Let's see, get us started, please. How about, whoa. How about Samuel? Go. Point 16. Gross comedy, point 16. Hands if you got that. All right. Give me another one. Point 2. Hands if you got that. All right. Oh. Let it go. All right. So you should have gotten point 36 right there. Yeah? Okay. Eric, go. Point 22. 0.08. So therefore this is point 3. Let's go. Let's see. Zach, go. Point 1. All right. How about boys? 0.24. Hands if you got that. So this is 0.34. Yeah? All right. Continue, Andrew. Oh, boys, 0.52. Which means this is 0.48. Yes? And this is 1. All right. Conclusion, tell your neighbor what you conclude from the data, please. What can you conclude from the data? All right, let's see. Mel, what can you conclude? Girls prefer drama more than boys. Okay. Anything else? Bless you. JC? Boys prefer comedy over girls. Okay, I see that. And anything else? Pedro? There you go. Okay. Yeah, those are good observations. Yeah. All right. All right. Agenda for today, warm-up number 8. Today we're looking at dot plots and standard deviation. And your home plate for tonight, have a good day. How about that? Yeah? Is that okay? Just because it's going to be 114 and I don't want your brain to fry. 114, can we read that? I thought they said that it was going to cool off already. That. All right, so no asynchronous code today or nearpod code. Last night's home play was the same tables but relative frequencies, yes? All right, so go to Canvas and turn in a picture of your home play. I'll give you some time for that. Then get a Cornell note ready once you do that, please. All right. So our objective for today, I can represent data on dot plots and compute the standard deviation. I can represent data on dot plots and compute the standard deviation. So once again, as we are navigating ourselves through the first 2-3 weeks of the school year, we're going through foundational stuff. This is just revisiting some of the items that we've seen prior to this course, and hopefully it's not been overwhelming, right? Fairly Fairly doable, yeah? Yeah? All right, good. Yes. Yes, since today we're looking at dot plots, you do need a fair model, please. Our concept for today is dot plots. We are also looking at a different main idea, which is standard deviation, but I'm only gonna do like a quick intro again, because we are gonna be heavily on standard deviation in the course. So today's just like kind of like a big glimpse to what we've seen before, okay? All right. So with that said, prayer model for dot plots, get that ready please. Definition. A dot plot is a data representation that uses a number line and X's, dots, or any other symbol to show frequency. Example. There it is. I'll give you some time, copy that. All right. So according to the definition, dot plots is a way of using data representation on a number line using X's, dots, or other symbols to show frequency. Okay, there we are. Okay. Let me show you a non-example. Hold on. Give me a second. All right. Write that non-example down and tell you why that one's not a dot plot. Why is not a dot plot? Pretty straightforward, yeah? You guys remember these? Some of you? Some? Yeah? Okay, good. All right, so hopefully you know why these are dot plots and why these are not, yes? So just for the sake of time, hashtag only one number line, shows frequency, uses X, dots, or symbols. Here we go. Writing utensils down, look up to the screen, and it reads. Example 1A. An ice cream truck offers items at 5 different prices. Mr. Q counted how many items are offered at each price one day. Make a dot plot of the data. There's a table, there's a number line, and what can you conclude from the data displayed? All right? So, let's do this one together. Copy example 1A, just copy the table and draw a number line, please. We'll do this one together. Who? Alexa? Okay. I'll give you some time to copy. So what can we scale my number line, guys? What can I start with and scale it? 1, 2, and 3, okay. 1, 2, 3. 0.5? Okay, so I heard 0.5. Let's find out. So 0, 0.5, 1, 1.5, 2, 2.5, like that? Yeah, okay. 3, 3.5, 4, 4.5, 5, 5.5, 6, and I'll stop right there, yeah? All right. So, what do you want to use? Dots, X's, what? X's? Okay, I'm going to use dots. So, $1, 5 of them. We got 1, 2, 3, 4, 5. 3 at 150. 1, 2, 3. 6 of $2. 1, 2, 3, 4, 5, 6. 4 of 250. 1, 2, 3, 4. And 2 of $3. 1, 2, 3. Pretty good, yeah? Oh, 2. Yeah, I did that on purpose, see if you were paying attention. There you go. All right, so you never, what can you conclude from that data? What can you conclude from that data? All right? So what can we conclude from that data? Samuel, what can we conclude? Most items cost $2. Okay, not bad. So if I go to Best Buy, I'm going to find an item for $2. No? Yeah, let's just, whenever you're, guys, so this is where I'm going with this. Whenever I'm asking you to share conclusions, try to be as specific as possible in relation to the data that you are given, okay? Right now we're going baby steps, and I'll take that, that's fine. But from this point forward, you need to be a little bit more in detail with, you know, elaborate with your words, okay? And I'm pretty sure, I mean, you guys are seniors by now, you guys know how to write your brains out, right? So make sure just elaborate a little bit more, okay? All right, so I did this one, you do this next one. Here we go, example 1B. There it is. And it reads, the cafeteria offers items at 7 different prices. Mr. Apodaca counted how many items were offered at each price one day. Make a dot plot of the data. There it is. I'll give you some time. Ready, go. To give us the conclusion of this data, what can you conclude from what you came up with? Let's see. Mel, pick someone. Who? Maddie, what can you conclude? Most items in the cafeteria are priced at $3. Is that pretty accurate, by the way? How much are the prices here? It's free? They don't sell anything outside of the cafeteria? $1.25? Really? Must be nice. I remember when I went to school as a senior, I remember whenever they had pizza, we had to buy the pizza. It was like $5 for the whatever they gave us and stuff like that. Yeah, I know. And then the other, there was a little truck they used to park outside of the school, and they used to let us out. And I used to go buy me a torta of egg with weenie. I don't know. I like the egg with weenie, so it was good. Anyways, from 1 to 5, how comfortable are you with these? Yeah, 5, right? All right. Ready to crank it up? I wanted to start with this one. All right. So, look up. Don't write this down. There's 4 steps, but I only made them 1. There you go. Identify the mean, median, mode, and range. Do we know how to do that? Do we know how to identify the standard deviation? Yes. You probably forgot, but yes, you do. Graph the data on the dot plot. Do we know how to use a dot plot? Yes. And do we know how to summarize? Yes. Okay, ready? Copy this. Example 2A. Oh, yes. Oh, yes. Example 2A reads, find the mean, median, mode, and range and standard deviation. Now, for the sake of time, we already know how to do mean, median, mode, and range, yes? So right now I'm going to focus on what? Standard deviation. So this is going to be an example of standard deviation. So copy this data, copy the table, make sure you label it, give you some time for that. Y'all ready? Here we go. First things first, let's organize this data here on the column of data value from least to greatest, All right, get us started. Jack? 1. Thank you. There you go. Next, tell your neighbor how to find the mean of this, the mean of that. All right, so find me the mean, and underneath, instead of writing the word mean, I want you to write X with a little bar above it. From now on, whenever I show you X with a bar above it, that means, that is the mean. How about that? Better? Yeah? That means mean? Means mean. All right? Tell your neighbor what you got for the mean. Everyone? 3. Yes, so we add all data, divide by the number of data, and that gives us the mean. Okay? So now look at the formula here that I gave you for the next column, deviation from mean. You take X and subtract, what is this? The mean. So you're going to put minus, 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 minus. And I'm going to write 1, 2, 2, 3, 4, 4, 5. All right? So find me that number, and I want you to write it in the next column right here. Not in the middle, but towards the left side right here. For each of those. Okay, help me out. Amy, go. -2, -1. All right. So far so good, yes? All right. Oh. Next, put these in parentheses squared. And write the numbers there. All right. So, -2 squared is 4, 1, 1, 0, 1, 1, 4. So far so good? Yes? All right. So, now this is, and the reason I'm showing you just the mechanics of it, this is just the mechanics of how to identify the standard deviation. We'll get to the standard deviation once we get into the course. But this is what gets a lot of college people tricked up that they feel that they're doing repetitive work throughout the data crunching. Because watch, now we have a bunch of data numbers here in this column. What do you think we're going to do with them? Yeah, find the mean again. So find the mean one more time, but this one you're going to label it squared, and that is called the squared deviation, once you find the mean of these numbers. So find the mean, please. All right, check with the neighbors, see what they got for the squared deviation. All right. We good? JC's got it, you said? Okay, JC, what'd you get? 1.7. Hands, have you got that? All right, is it exact or approximate? Okay, put the wiggles on that. Okay. All right. So let's go through the process one more time. You are given data, you find the mean. From there, you take that mean and subtract it from all the data. That's what we call the deviation from the mean. The data, how far from the mean, and I'll explain the deviation in a little bit. From there, we take that difference, we square it, and then we find the mean again, and that's what we call what? Squared deviation. But do we need the squared deviation? No, we need the standard deviation, which means we need the deviation by itself. Here it is. How can I leave the deviation by itself? Tell your neighbor, if it's squared, what do we do? Very good. Take the square root. So do me a favor, get your calculators out. Find me the square root of 1.7. All right, square root of 1.7 is, Matthew, you got it? 1.3? 1.3 approximately. Hands, if you got that? Looks about right. This is our standard deviation. Okay? Now, I'm going to stop the video at this point. And once again, if you need to revisit, just go to the video. However, I want you to do this next one by yourself. Thank you, Mr.